Hey, Jonathan here at the Colfax High Mill and Wood Shop. This channel is TopSaw. It's all things wood. I was a building contractor, framer, finish before I started teaching. But today I'm going to go over the plumber and steam fitters union entry exam in math. I got some pointers and I'll just do a lot of these problems. And I'll actually give you this test as a link in the description. So stay tuned and I'll run through this test and hopefully it'll help with the plumber's union math exam. It's pretty much the same for most of these standardized exams. All right. Five main strategy is prepare, watch a video like this, do a lot of practice problems, prepare so that you are relaxed at the day of the testing. Get to the test early, sit down, make sure you have your pencils, you're ready to go, take a few deep breaths, and do the best you can by relaxing. Number two is pace yourself. Don't ever get overly worked up on one problem and stuck there and waste a lot of time there. Figure out what your total time is, divide that by the number of problems, and then spend about the right amount of time on every problem. You want to mark up, number three is mark up the test as much as possible. The reason why you mark up the test is that if you have extra time and you go back and you want to check your work, there's a lot of really clear work you could check. Or if you skipped a problem and you go back to it, you don't have to start all over again. You could continue on from where you left off. If you're having a hard time on a problem, look for specific cues that they give you. There's usually like a little trick or something to the problem. So look for those cues and they might kind of help you through a sticky spot. And then really be thorough and slow and careful. You got to do all the problems carefully. The hardest problem on here has the same weight as the easiest problem on here. So don't miss a bunch of problems that you know because you're racing or you're not being thorough. Okay, so those are my five kind of test-taking strategies, and let me work through some of these problems. We start with addition, subtraction. The key here is really place value. You want to add up and then carry correctly. So 5 plus 4, 9, 17, carry the 10. I'm marking it all up. 8, 10, 13, 14, carry the 1, 6, 7, 8, 17, and there it is. Same with subtraction. Like the opposite's true on subtraction. You're going to have to borrow the 10. Multiplication, including decimals. Here with multiplication, let me jump down to 7. You got to keep track where the decimal place is. So it's here and here. I'm going to multiply the ones place first. So 5 times 6 is 30. Carry the 3, 35, 6, 7, 8. So that's 38, carry the 3, 25, and 3 is 28. Next I go over, and then I'm going to put a 0 here. I'm going to multiply that through all of them. 0 times anything, these are all zeros. And I'm going to add these together to get 0, 8, 8, and a 2. And then I do the total number of decimal places this decimal is over. So it's 1, 2, 3, 4, 5. So I need to start here and go over 1, 2, 3, 4, 5. One more. So it's going to be 0.0288. Okay. Division. Here's long division. I think I'm going to skip that one and go down to the division in feet and inches here. So it is important to answer in both feet and inches. I have 8 going into 34 feet, 8 inches. I guess there's a couple ways you could do this. One of which was you could go 34 times 12 plus 8 and put the whole thing in inches, and then divide it out and then come back. The cover of this said you can use a calculator. My student thought you couldn't use a calculator. But if I do it that way, I have 34 times 12, 34 feet times 12 inches, 408 plus 8 inches is 416. So I have 8 going into 416 inches. So 416 divided by 8 is 52 inches. 52 inches, 12 inches to the foot, is 48, is 4 feet, 4 inches. So 48 is my 12 times 4 with 4 inches left over. So that's probably the easiest way to do it if you're allowed a calculator, or you can multiply it out. Without a calculator, you say 8 goes into here 4 times to give you 32 feet. 34 minus 32 feet is 2 feet, 8 inches, right? 2 feet is 2 times 12, 24, 32, right? So this is really 24 inches plus another 8 inches is 32 inches. 8 into 32 inches is 4 inches. So that's another way you can do it. Okay. Similarly with gallons and quarts down here. Move on to the next page. So this is saying at $29.12, how much money are you going to get paid for 39.5 hours? So that means I have 39. This is a decimal. I'm going to turn that into a decimal. 39.5 hours. So I'm going to multiply those two together. I could use a calculator to do that. So I have 29.12 times 39.5, or I could use long multiplication to get 1150.24. And that makes sense, right? 40 hours is about a week of work. $30 an hour times 40 hours should be about $1,200. So that looks about right. Okay. So another unit conversion. And then down here, a column of water is 2.31 feet high, and it exerts a pressure of 1 pound per square inch. How much pressure does a column of water 46.2 feet exert? So when one ratio is equal to another ratio, that's a proportion. I'm double checking my units here. This is also feet, and this is what I want to know here. So 2.3 exerts 1. What does 46.2 exert? I cross multiply here. This times this is equal to that times that. So 2.31x is equal to 46.2. I have to divide both sides by 2.31. I can see it actually is going to work out to be an even number, right? This is 462. So this is going to be equal to 20. Okay, which kind of makes sense. So 2 feet are exerting 1 pound. So 46 feet are exerting 20 pounds. So that's 20 pounds of force there. Okay. Turn the page here. Some geometry. It kind of looks intimidating, but actually isn't so hard. So a couple of things I'm going to do here is really highlight, the keyword circumference. That's the distance around the outside. Area is the amount inside. So what's the circumference of the circle? It tells you circumference is equal to pi. That's a number, 3.14, times diameter. All right. You don't have a diameter, you have a radius. So you need to know that the radius is half a diameter. So if the radius is 24, all the way across is 48. So my circumference, I give it to you here, is equal to 3.141 times 48. This is inches. I'm going to do that on my calculator, or I can multiply it out. 3.141 times 48 gives you 150.77. 150.77 inches. So around the outside of that circle is about 151 inches. Area is this equation right here. So my area is equal to pi. They give it to you there. 3.141. Radius, 24 24 squared. It's important to do these operations first. So you want to square first and then multiply by that. So here I'm going to go 24. Here's a square key, but that just means 24 times 24, 576, times 3.141 gives me an area 1809.2. So my area is 1809.216. Because I'm squaring my units here, this is now square inches. So area is going to be two-dimensional instead of a one-dimensional length of a line. All right, still kind of in the geometry realm here. This is a right triangle, and it's telling you use this formula. What's the length of C? So that says you got to take this, right? 15 squared plus this squared is equal to whatever that is squared. So 15 squared, I think it's 225. 225 plus 20 squared, 400, is equal to C squared. 625 is equal to C squared. I got to get rid of that square, so I take square root of both sides. That and that cancel. That gives me C by itself. And what I'm looking to do here, this is my square root button here. I don't know if you can see it. This is a square root of 625, which is 25. So that's how you use that formula to get a C length of 25. Or you might remember this too. This is actually a 3, 4, 5 triangle. I mean, when you're trying to get things square, you work with the 3, 4, 5 a lot. Let me change the colors on that. And I know it's a 3, 4, 5 because 3 times 5 is 15. So 3 times 5 is 15. 4 times 5 is 20. 5 times 5 is a 25. So that's the Pythagorean theorem. It helps if you know the 3, 4, 5 triangle because the ratios will be the same. Over here, kind of in the geometry realm, what is the measure of that angle? Well, you got to know all the way around the whole circle is 360 degrees. So half a circle is 180 degrees. I don't want a half. I want 1, 2, 3, 4. I'm going to take that 180 and split it in 4 to get 45 degrees. So what's the angle of that? It's 45. This is just kind of a pure algebra equation. So you just got to know the rules of algebra. The whole goal here really is to get the x by itself. So the way I'm going to do that is I got 5 of these x's and 4 on this side of the equal sign. I'm going to subtract these 4 from both sides. That's going to give me 1x plus 20 equals 30. Still trying to get that x by itself. I'll subtract 20 from both sides to get x is equal to 10. No units here. You're just solving algebra equation. Here, same thing. You're getting this by itself. The way I get rid of that negative 40 is I do the opposite. So I'm going to add 40 to both sides of the equation to get x equals 100. So here, combine it similar to that one. This equal sign is treated like a balance. So you can do whatever you want as long as you do it to both sides of the balance and it stays in balance. So if I add 40 here, I add 40 here. Fractions, these are kind of the key. The big thing to differentiate is that there's a set of rules for addition and subtraction. And that set of rules is you have to have a common denominator. So you have to have a common denominator versus the rules for multiplication and division are different. Multiplication, you just go across the top and across the bottom multiplying. Division, the rule on division is you flip the second number. So the second number is flipped and then you multiply and then multiply. Okay. So addition, subtraction, I have to have a common denominator here. This is 6 and 5/32, and 7 1/8. They're both going to go into 32. So I have 6 and 5/32 plus 7. Now I got to get this into a 32nd. I know it's hard to see. 1/8. So I'm going to multiply it by 4/4. And that's going to give me 32 on the bottom. So that's 4/32. Now I have that common denominator. So in a fraction, the top is the numerator. The bottom is the denominator. So I got that common denominator. I add across the top. 5 plus 4 is 9. I keep the bottom number the same. So I get 9/32. I'll just add those numbers to get 13. So that's really the key on fractions. I'll just do one more. So I got 13 and 1/8. Common denominator is 8. To get this 1/2 to an 1/8, I got to multiply it by 4/4. That'll give me 4/8. So I have 6 and 4/8. 1 and 4 is 5, keeping the bottom 8, and then 13 and 6 is 19. Subtraction, same thing. Multiplication, even though it's a harder operation, multiplying fractions is easier. So this is 1/4 times, even though it's an integer 28, they're all fractions. So think of it as a 28/1. And now I can just multiply across the top and the bottom, but what I usually do before I do that is I cancel. So 4 will go in here once, 4 will go in here 7 times, multiply across the top to get 7/1. Here I have mixed number. I turn it improper fraction. The way I do that is I take that whole number, multiply by the denominator. So 4 times 4 is 16, plus 3, add the numerator, is 19/4 times 1/2. I'll just go across the top, 19/8. I could leave it like that. I'll just do one division problem here. So again, I have 3/4 divided by 1/4. The rule is to divide fractions, you flip the second term and multiply. Right, so down here I have 3/4 times this thing flipped over, 4/1. I could cancel 4 going to here once and here once, leaving me with the 3. All right, keep going. It's getting longer than I thought. Decimal addition and subtraction, the same rules apply for addition and subtraction. So with decimal addition and subtraction, you line up the decimal point. So here all the decimal points are lined up, and you just add straight down and you bring that decimal point down. Same with subtraction. Multiplication is different. Like that first problem, you keep track of how many decimal points over it is. So this is over 1, 2, 3, and here it's not over at all. Right? So here it's over 1, 2, 3 plus 1, 2. So here I'm just going to multiply 0, 0, 0, multiply that 0, 0, 0, 0, multiply that 2. 2 times 6 is 12, carry the 1, 4, 5, 8. I'm going to add all those numbers together to get 8, 5, 2, 0, 0. And I have to move my decimal place over 1, 2, 3. So I move my decimal over 1, 2, 3. And I end with 85.2. That kind of makes sense because I got 200 times about a half, which should be in like the 100 range. All right, I know I'm talking a lot here. Here I'm going to do long division with decimals. I'm going to turn this into a 20 by moving the decimal point over 1, 2. We do the same thing here. I move it over 1, 2, and bring it up right there. So then I do 20 goes in at 824, and if there's a remainder, it goes up there. So that's long division. Let's see what else we got here. Converting decimals into percentages and back and forth. Let me jump down here first. So if I have a percent and I want it in a decimal, I remember this thing is like an arrow shooting it over 1, 2 places. So my decimal is here, I shoot it over 1, 2, and I get 0.35. So if that's how I go from a percent to a decimal, the way I go from a decimal to a percent, the way I go from a decimal to a percent is I shoot it over to the right. So 0.25 is 25%, 46%. I gotta shoot it over twice. I'll just talk through that phone, right? I'm shooting it over twice, so that's gonna be 2.25. Best way to multiply percents by a whole number is convert it to a decimal. So I have 250 times 0.25, and then I multiply those together like we did before. This is saying find the missing percentage. So 40 is what percent of 50? So it's saying 40 is what part of 50, right? That's what it's saying. So the way I do this, fraction to a decimal, I think that this fraction is standing upright, and it's going to fall over this way. And what I'm saying is 50 goes into 40 when I drop it over. Here's my decimal point, right? That's 40.0. 50 doesn't go into 40, but it goes into 408 times. So that's 0.8. So that's the decimal of 0.8. Make it into a percent, 1, 2. 40 is 80% of 50. All right, let's see, what's the interest on that number for 1 year times 5.5%. So this is 5.5%. I convert that into a decimal over 1, 2, 0.055 times that dollar amount, and that'll give me the interest. Okay, this algebraic equation to convert Fahrenheit to Celsius, you would take that Celsius amount and plug it in there to get a Fahrenheit. So it's saying, what is the Fahrenheit temperature when it's 80 degrees Celsius? I take 80, plug it in there. So my answer, Fahrenheit, is going to be 9/5 times 80 plus 32. So here I'm multiplying fractions. All right, this is really 80 over 1. 5 goes into 80 16 times. So 5 will go into here once, into here 16 times. So my Fahrenheit is 9 times 16, 90 and 54, 140. I better write that one out. 16 times 9, 54. That's where I'll make a careless mistake and lose all the points on the problem. So better be safe. So I got 9 times 16, 144, plus 32 is 6, 7, 1. So 176 degrees Fahrenheit's my answer, which is hot, right? I mean, it's burning hot, but 80 degrees is pretty close to boiling. I mean, you got to remember 100 degrees Celsius is boiling. All right, last page. Setting up ratios. I didn't mean to go so crazy on this test. I mean, do the whole thing. So one ratio equal to another. So it's saying find the value of V. That's what I'm looking for when P is equal to 4. So it's telling me P is equal to 4. There's P. P1 is equal to 6. There's P1. V1 on the bottom there is equal to 8. So again, I cross multiply. That times that equals that times that. So I say 4 times V is equal to 6 times 8. 4V is equal to 48. Divide both sides by 4. And V is equal to 12. Let me just inspect that. 12 is to 8, as 6 is to 4. That's right? This is times 2 times 2. That works. So let me jump down to these ruler ones. This one right here, you just have values and you plug them in. They give you all the values and you're solving for a specific weight. Down here, I'm on my ruler. I count 1, 2, 3, 4, 5, 6, 7, 8. So these are all 16ths. Right, here's 1 inch here. So this is half. So each mark is a 16th of an inch. And then this measurement here from 2 to 5 is 3. 1, 2. So that's 2/16 or 1/8. All right, well, I sure hope that helped. If you're taking your union test, just kind of go back to these strategies, really prepare so that you show up and you're relaxed, not worked up, get there early, pace yourself, mark up your test as much as you can. So if you go back, you can see where you left off. Look for the cues. A lot of things will cancel or cross out, and really be careful. The hardest problem on here has the same weight as the easiest one, so don't make any careless mistakes. All right, so this is Jonathan at the TopSaw channel. It's really all things wood. I was a building contractor, framer, but it's all kind of the same math. So hopefully that helped. Thanks for watching, and if you liked it, go ahead and hit subscribe.